I am welcoming you all to this video where we are continuing with this topic of solving second order differential equations, linear, and they are homogeneous, where the complex conjugate roots arise. They would look like a plus minus bi. Then our solution would take this form. The a and the b would come right over here. A right here, the b right here. The capital A, the capital B represent the two constants. Since we're looking at second order, they should have two constants generate in terms of the solution. The capital A, capital B can be represented using another designation, C1 or C2. But let's look at two questions here. You've seen some of this in the previous video, so let's review it here by means of two examples. Our first question can be this: d square y dx square plus 5y is equal to 0. If you were to rewrite this, you can do y double prime plus 5y is equal to 0. When you're looking at something like this, you're thinking about that all important substitution. If y is equal to e to the rx, the y single prime is equal to r e to the rx, y double prime is equal to r square e to the rx. You bring these into play where and when possible. I have a double prime right here, so it'll be r square e to the rx. Then I have 5, and then the e to the rx is equal to 0. You isolate the e to the rx, you'll have r square plus 5 equals 0. You can essentially solve for this and push that on the other side. This will zero out. You're looking at r square plus 5 equals 0. R square is equal to minus 5. R is equal to plus and minus square root of minus 5, which would be, as you can imagine, plus and minus I root 5. But you can make the picture a little bit more complete by saying 0 plus and minus I root 5, so it looks like this. Now when we bring everything into our final equation form, this right here is my a, this right here is my b. You bring it here into this template that you see right over here, this template, and it would be y is equal to e to the 0x, which is 1. You would just have a cosine bx, which is root 5x, plus b sine root 5x, and that would be your solution. Y is equal to a cosine root 5x plus b sine root 5x, and it should be right. So you can remember how this question is done. It's not hard. Everything will be solved in the normal quadratic route. Then in the end, you'll bring your answer here into this form. Now imagine if you're looking at this question here, y double prime plus 2y prime plus 2y is equal to 0. We have to solve this out. How do you think you'll go about doing this? Well, you bring in those substitutions. This will be r square e to the rx. This will be 2r e to the rx. This will be 2e to the rx. I have the substitutions here on the side for you. Isolate e to the rx, and then you're bringing here r square plus 2r plus 2. You can't solve this in the normal route. You have to use quadratic formula. Minus b plus minus square root b square minus 4ac over 2a. If you were to solve for this and push this on the other side, this zeroes out. So you're looking at just this, and you bring in the quadratic formula to determine your roots. When you do that, this here is your a, this here is your b, this is your c. You're getting a minus 2 plus minus b square, which is a 4, minus 4 times 1 times 2, all divided by 2. Simplify this, you get minus 2 plus minus. Here you're getting a 4 minus 8, which is a minus 4 over 2. This comes out here as a 2i. So you have a minus 2 plus minus 2i over 2. When you simplify this further, you have minus 1 plus and minus I. This minus 1 plus and minus I looks very much like a plus and minus bi. Then you bring everything here to this template. Here the lowercase a is minus 1, the lowercase b here is a 1 because it's a 1i, a hidden 1. Anyhow, you bring it here into your solution. Your solution is y is equal to e to the ax, which is a minus x. Then you have a, your constant, one of your constants, cosine bx, b here is a 1, x, plus b, which is your other constant, sine bx, that. If you want to make it look better, get rid of these 1s because they're irrelevant. This right here is your final answer. Y is equal to e to the minus x, parentheses a cosine x, plus b sine x. These two are my constants, and my minus 1 and my positive 1 are these lowercase a and b, which are coming here from your complex conjugate solution. That's all you need to see here in this particular video. Thank you for watching.